Hello and welcome to a buildingSMART webinar. This webinar is part of the buildingSMART Virtual Summit for Spring 2022. Thank you for joining us today. My name is John Proctor and I am your moderator today. Details of today's webinar are on the screen. We are having an expert panel on IFC 4.3. This is a joint presentation by the infrastructure and railway rooms. As you'll see, we have an introduction and MVD development. We have scope settings, test instructions, certification, and information on the ISO submission and timeline. Speakers today are as listed. We will hear from Karin, Ronald, Sergej, Evandro, Matthias, Lars, and Christophe. The webinar is scheduled to last for 1.5 hours, and we'll have a short question and answer session at the end. The webinar is being recorded and will be made available in the replay section of the event within the next 24 hours. Before I hand over to our speakers, I'd like to remind you that your phone lines will remain muted for the duration of the webinar. If you have any questions or wish to make comments, please use the chat function in the control panel in the Zoom screen. So questions and comments, please place them in the chat. I will be adding a link in the chat to a feedback form for any expert panel members who wish to provide feedback on today's presentation or indeed on the IFC 4.3 standards that have been issued so far. I'd like to bring to your attention the information that is on the screen now, that we at buildingSMART are committed to ensuring that participation in development of standards is unrestricted and the process for their adoption is transparent, and that standards that are developed do not favour any particular provider, but are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. Okay, thank you. I'm going to pass over to Karin. Karin, if you want to share your screen, we will get the presentation underway. Thank you. Yes, we can see your slides.
Thank you, John. My name is Karin Andersson. I had a presentation regarding the IFC 4.3 infraroom part on Monday, and I'm just going to repeat a couple of those slides. This type of expert panel is something that we've been doing in the infraroom projects for the last few years, and it's a way of us to convey to you on a regular basis the results and what we've been doing for the last few months. We've now come to the point where we have gone through the requirements analysis of all the projects. We have created our conceptual models. We've reached candidate status. We've done a validation verification, and we've communicated the standards at many occasions. I think I've spoken now in every summit for many years, the last 5 years at least. And at the last summit, Jim Plume had a presentation, a plenary presentation, where he celebrated the people who had been involved and went through the very long history and timeline of the project. So that is a place where you can look for more detailed information. The result of our previous work is all available in some way or other in reports or in databases on the buildingSMART.org page. Here's the timeline. You see that we have reached the goal of many of our projects. The IFC rail and infra projects have reached an end. The tunnel project is still ongoing. The railway room and it has planned for a continuation. The infra room has got its roadmap and will work from that. And now we've come to that blue arrow that's just at the bottom there, going across the purple line, and this is where what we are going to present to you today, the work that we've been doing with the base MVDs and the preparation for certification. There you will also get a quick overview of information regarding the ISO process and what's been going on there. That's really all I've got to say today. I'm very excited to introduce the following speakers to you, and Ronald will start that introduction. Ronald Bergs, thank you.
Thank you, Karin.
Do you want to share your slides, Ronald?
Yes. I'm almost there.
Yeah, that's it.
Can you see them? That's
yeah,
it.
It looks good.
Great. Yes, so I'm taking over from Karin. So both of us have been leading the project of development of the model definition for the alignment-based reference view. As said by Karin, it was a joint project from both rooms. And apart from the ones who are presenting today, about 5-6 people, there are 10 other team members which have been working very hard in order to achieve these results. And they might also be in the Q&A to answer some questions when they arise. I will start with giving you an overview of what alignment-based reference view is about, and then while our other team members will go in more detail about, for instance, the scope settings, which will be done by Sergej and Zhang, the test instructions and the certification. Certification will be done by Matthias, who is actually our client who will receive the alignment-based reference view for configuring the BCert certification tools and in order to be able to start the certification. I'm going to start with the introduction. So the objectives of the project alignment-based reference view is to provide the software certification team with the information they need to start that process. We are delivering and the model definitions in order to ensure interoperability between software vendors, so that there is one common basis, which is based on IFC 4.3, where software vendors can certify themselves on, and where the organizations who would like to acquire certification
Ronald, it's
can refer to.
Sorry
Yes.
to interrupt you. Your slides are still on the title slide. Are you intending that, or do you need to move the slides on?
I'm a little far. Can you see now?
We're on objectives now. Yeah.
Okay.
Yeah.
Well, it's in the presenter mode, but it doesn't show the slides then. Another thing is as important is that the model definitions are based on user demand, so that we are referring to storylines, unit tests that has been performed that we built up on this input from the previous phase 1 as part of the IFC 4.3 development. So then you should go to the next slide. So the process approach for this is that for us it's important to have a triangle of domain experts who requiring contents inside the alignment-based reference view, what they should, what they would like to use in practice and to ask certification for. Of course, we have the software vendors who are asked to implement these requirements in order to have, in order to be able to certify and to be able to exchange data between different software vendors. And we have the technical experts, and these are meant that's actually our team who was able to translate the requirement from the domain experts in the previous phase into the IFC 4.3 development, and they also use this to translate that fundament into test instructions and scope setting for the alignment-based reference view. So this is still an ongoing process. So as we speak, the expert panel is one moment where we can inform you about this development. We can ask you for feedback, and also the implementers meetings on Fridays. They are used in order to inform the software vendors and to ask for review and to see if there are some improvements, so that we have at the end a feasible package of alignment-based reference view, which is useful and feasible for software certification, and that will go in the next process of the BSO team. So the next slide, the time schedule. So we started in November with an approach. So the approach was a bit different as it was from the last reference view MVD, because we had two projects in parallel. We had one project who was delivering the official IC for the 3 documentation and its general usages, and our team had to deliver the MVD, and both have to be merged together into one package for the certification. So what we see is in this timeline is that our team has delivered two things: the scope settings. So it's a selection of the part of the IC for the 3, which is defined as the scope for alignment-based reference view, and we have the test instructions, which are very specific on referring to some capabilities, what should be certified, what should be tested. We haven't achieved all the test instructions for all exchanges, so we will have another batch in April in order to finalize that. That's the yellow part. We are now in the middle of the review phase, as I talked about, and the merge of the 2 projects will also lead to the encoding of the MVD and the official publication. That will also be done in April. So what we're now showing is actually the specification of the alignment-based reference view, and the technical translation is done in the next month. If you look at the scope of the alignment-based reference view, this is important to realize that we already have the reference view, which is based on IC 4.0, and this is actually a basis of how to start or to configure a project. And the alignment-based reference view is built on top of that, so it has additional requirements to be used for rail and infra. The scope is defined as we only will have these things in scope which have a relation to alignment. So if we talk, for instance, about bridge, it only has the it should have the reference to alignment, and this reference can be semantical. So that's the more or less the definition line of what's in scope or what's out of scope. We have a lot of exchanges defined inside the alignment-based reference view. These are the right ones, which are more the light blue ones, and you can read them from top to down. And especially for the alignment reference, we have some differences between alignment used for infra and rail, and they have been divided into sub exchanges or sub exchanges of the alignment. We have a reference for super elevation and for Kant, but both built on the same alignment reference, which is called E1, and the same code for the structure. Then go to the next slide. I already said that we built on the basis of our alignment-based reference view. This can be found on the website of buildingSMART. It's documented over there. So if you follow the link in this sheet, the sheets will be provided as well, I think. Then you can have a look at what's already inside alignment-based reference view. And if you have the final documentation ready, it will also be published on this site. I talked about 2 deliverables. The first deliverable is the scope selection of the alignment-based reference view. That means that we have to make a choice of what is inside that specification, and it's of course involving everything what has been developed in phase 1, and everything what is needed in order to use these additional specifications. I don't go further into this. I will leave it to she and to Sergej. The second deliverable is the test instructions, and these test instructions makes it understandable of actually what should be tested inside an exchange, what is important because of that of what domain experts are expecting from their input in phase 1. And in the test instruction, this has been made explicit how this should be tested. And the test instructions will also be provided in more detail by Evandro and Lars, so I won't dig into that as well. It's important to understand that we didn't make anything from scratch, but we, of course, we used as much as possible the things we had from the phase 1. In phase 1, we had some unit tests, but I have to stress that it's not the unit tests. It's not that we have made the unit tests into the test instructions. It's not a one-on-one translation because some unit tests were not compliant to the IEC 4.3, but we have looked at these unit tests and looked at these storylines to understand, okay, what can we use as a basis in order to make the test instructions for the alignment-based reference view. These are some sheets. They are available on the GitHub, and these are showing you the unit tests which are delivery of phase 1 of the previous phase. And the unit tests have been used by software vendors to test also some parts of the IEC in order to understand how things can be implemented. But Evandro will also go in more in detail about the difference between the unit tests and the test instructions. My last slide, one of my last slides, is the test instruction itself. This is an overview of the exchanges which are inside of the alignment-based reference view on the right-hand side, and the codes and the test instructions which are currently available for these. Then I would like to conclude with 2 slides. First of all, the challenges. So we had a very tight timeline, and our resources were also required for review IEC 4.3 for the ISO documentation. But nonetheless, we achieved a very, I think, good work in order to have a nice specification, and also the cooperation between infra and rail went pretty well. And we had also the challenge. We had also challenged that we had that second project, which was delivering the IEC 4.3 documentation, is also a very tight timeline. And now we have to bring these things together. So we had to wait also for the completion of that, and that made that we couldn't start with a good basis because it was in development. But nonetheless, we achieved to make this deliverable. So the next steps is the review improvements on the current specification. So we are asking you as an expert panel, we are asking domain experts and software vendors to have a look at it and give feedback on that to see where we can have some improvements. We have, for the said, an additional batch of some test instructions which are still missing. We have the technical formalization, which will be done by another team who will encode the MVDs. And then if these are encoded, the beta team will use them to set up the toolset. There will be publish a formal documentation, and which will be published on the website that I showed you before. And then the process will be installed for the certification, and the certification will start. But also the certification will be explained in more detail by Matthias later on in this presentation. So these were my last slide, so we can continue with having a better look at the scope settings. And we'll ask Sergej and she to take over, please.
Thank you very much, Ronald. I would ask you to go to the next slide, please. So, first of all, let me introduce myself. My name is Sergej Muhic. I will be presenting the scope selection process and the tools that were used for this. I will also give you a live demo of how to access our deliverables, how to access our work, how to read it, and how to preferably give us feedback. That being said, let's just start with the process. So what we have been trying to implement is also some sort of a bit of a different approach where test instructions would be the basis for an MVD, but this was in the process, when the process started, this was kind of really hard to do, because obviously if we don't have a specification available, it's quite hard to do test instructions. That's why our initial idea was modified a bit, where we imported the specification to BIMQ first. I will also show you how this looks like, how the tool looks like. This was then used to make our scope selection, meaning that from the definition of an MVD being a subset of the schema, the concept templates, the usages and the properties. We did that in this BIMQ tool. This was first of all used for the general scope selection, and it was also used for the assignment to exchanges. These exchanges kind of are subdomains of what software has to implement to be certified against this MVD. From this, we exported an MVD XML. This MVD XML was then used as an import to the IFC specification repository on GitHub. We automatically hooked up the templates to the usages and to the exchanges defined, which kind of made our settings for scope selection available inside the IFC specification. And from this, we can then generate the HTML documentation that I will show you, and which we hope you will use for feedback. And from this HTML documentation, you can also extract the subschema, subset of properties, subset of templates, subset of usages of this MVD. And here I would ask you to go to the next slide, please, Ronald, and then I would. This is just a summary slide. Please treat it as such also. It's supposed to give you a couple of links and an overview of the documentation, how it's supposed to look like. We have the MVD specification repository on GitHub. You also have a link to where you can post issues, which is the blue here underlined word. Then we have the MVD documentation, where you can download the HTML with all the computer listings, such as schema, property sets, quantity sets, and so on. And without further ado, I would then ask you, Ronald, to stop sharing so that I take over. Thank you very much. Now, just a recap of what I said before. First of all, the BIMQ tool, where we kind of imported the the IFC specification with the definitions, templates, and usages from general usage, which is not yet completely done, but it should offer a good baseline. You see the entity over here. You see the concept templates being assigned over here. And if we select, maybe, I think this might be an entity with properties already. We also have property sets separately assigned. And all of these concept templates, as you see, are inherited. So an IFC project is by definition an IFC context, which is an IFC object definition, which is an IFC root. So all of the inheritance structures is here. And all of the concept templates inherited from the parents of this entity are also applicable to IFC project, obviously. The property sets are listed separately, although there's a concept template behind it, but they are also instantiated with their proper names and members. How this is then done is that we have this scope selection exchange, which is called ADRB00. The scope selection is being done here. We're just adding these tick marks. And for individual exchanges, the code names are listed here. I think it actually gives me the full name if I hover over it. Exactly. So this is the alignment-based reference view, alignment reference can't exchange, which has a bit of a different scope. It has its own requirements that have to be selected and specified, and you see those in this column. Let me go then back to the first IFC root entity, just to show you how this works. What happens after this selection is that an MVD XML file is generated from BIMQ. This MVD XML file is then imported into the GitHub IFC specification. Sorry for that. Warning there, but it's imported into the IFC specification where the hookup to the concept templates is achieved. So let's just pick one that we already looked at. We have our IFC root. Unfortunately, IFC root doesn't have many instantiations of its usages, so it's pretty empty if we click on it. But what I want to show you here is that the hookup to the templates is done. And if we maybe go to something with a bit more content, like IFC project, you can see that the pset project common is assigned to the property sets for objects template, and it has its instantiation as a pset project common over here. And even further, debugging, sorry for that. For any further adjustment of rules or adding descriptions and stuff like that, so just instantiating this particular usage can be done through the tool. Okay, once this has been imported and the hookup to the templates and basically to the IFC specification has been done, we can then generate the documentation. This documentation is then generated as the alignment-based reference view as a separate publication, and it generates basically a folder structure, as you will see here. It generates this folder structure, IFC documentation, the version of the specification, and then you have the alignment-based reference view publication generated here with the subsets of the schemas. So if we go back to the publication in the Express folder, there are all of the schema subsets. There are there's also the XSD subset. And if we go to HTML, we have we can just start up the documentation by this index HTML. This is also documented in the presentation, so you should be able to reach it. What this starts up is this documentation. And if you go to scope settings, so this is our scope settings exchange. It's sort of a placeholder exchange that we are using to select the scope. You will find all of the definitions listed, plus their applicability to exchanges. So currently we are working on these 6 exchanges. Many of them are already done. And you can see that if you scroll a bit, you can see that property sets, usages are already selected for these exchanges. You can identify them obviously with these squares. And whenever there's still some discussion required, you will find that in the definition column where our comments are also posted. So basically, I have been using a keyword, not sure, or discussion. So if you look for something like discussion, okay, this was not exported, but let's say not sure. And if you find something like this is definitely up for grabs for now, and wasn't yet completely selected for the scope. So it could be that we can remove these pieces, for example, from the scope if they are not needed. You can also navigate this documentation further by, let's maybe just look for something that everyone is familiar with in the infrastructure domain, something like, let's just go for alignment count. You click on it, you get to the official documentation, and you can also then see the selection of these usages for individual exchanges. If you scroll down to the definitions applying to alignment-based reference view scope settings. Here you can then review what's required for import or export, and by this you can of course give us proper feedback. The next thing, and then I'm gonna finish, is the IFC specification where this alignment-based reference view is uploaded, is available through the link in the PowerPoint. You get to this GitHub repository. It's already set to alignment-based reference view documentation to this particular branch. You can then download this if you're familiar with this definition. You can download this, review it in IFC doc, however you would like. So you go to code and you can download as a zip. You can open with GitHub Desktop, whatever tools you're using. And for the documentation part, which is generated separately from the specification, you go to the other link, NVD documentation. It's also already set to this branch. So you come to the alignment-based reference view documentation branch. You download this one as a zip, and you will find the folder structure that I showed before. So it's 4.3.0.0, _00, ABRV. You go into this, and if you go into HTML and index, you can start up the documentation and review at your leisure. For the issues, we would prefer if you post them into IFC specification issues. So over here, but you can also use the other repository IFC documentation and the same issues tab over here for any issues you want to post. With that, I would finish and hand over to Chi. Thank you very much.
Oh, okay. Great. So just introduce myself. I'm Zhang. I'm working in the IFC Rail project. So we joined this project to provide input from Railway. And here now I just present the status of exchanges and try to give an overview of these exchanges in just a few slides. So I guess would be useful for you before you dive into details in the HTML documentation. As Ronald just said, there are 13 exchanges planned in this MED. So each exchange is kind of a subset of this MED. At the moment, there are 6 exchanges pending for review. So this alignment, there are 2 alignment-focused exchange. One's alignment reference super elevation, and one's alignment reference current exchange. So from the name, you can actually see the focus of these 2 exchanges. Then we also have 4, let's say, more domain-related exchanges that have this track signaling, energy, and telecommunication. Okay. So I just try to grab some the idea or to show you the conceptual things of this MED of these exchanges. So there are 2 alignment-focused exchanges currently pending for review. They are largely overlapped, so they have things in common, very basic things like project setup, this georeferencing, and have minimum spatial structure. It also covers alignment and stationing. And for the alignment, it covers all. They both cover the horizontal and vertical. And it's just the super elevation exchange also has the super elevation information, and then the current exchange has the railway current. Yeah, so these 2 exchanges are relatively small. So the idea is that to provide a very small exchange, and so they should be relatively easy to certify against. There's an open issue. The open issue is about this specific transition curves. This also, I think, has been discussed by many people already. So we also welcome feedback for this issue. Basically, because the transition curves, some of the transition curves are domain or national specific. So it's about including them all, but this will make the certification, the threshold for certification very high, probably. Or we should define some national extensions for certification regarding this national specific transition curves. Okay, next. Then, so I will just talk about the other 4 exchanges. So the other 4 exchanges, because they are all railway focused, so they all include the alignment, all the concepts in the alignment, the reference current exchange. So they are all supersets of alignment reference current exchange. So based on that, they also share some common features. So these common features are just some conceptual. This is just a conceptual structure, because you cannot find this structure in any MED documentation. It's just, in fact, they have these common things shared. So they have this linear placement, railway spatial structure, group and system, object typing, property set, classification, material association. So all these things, and a lot of them are actually inherited from the reference view. We have this railway spatial structure and linear placement. Okay, next slide. And based on these common parts, so besides alignment current, besides these common features, then each of these exchange also has its own concepts. Then they own, let's say regarding this, all these features, we can call it features, right? That the track has some specific requirements for geometry. So regarding this parametric geometry, advanced swept directrix geometry, and section solid horizontal. And then for these, the other 3 exchanges, signaling, energy, and telecommunication, because they are all like system or focused, so they also need to have this port connectivity to require this network structure between elements. And then for each of the exchange, it has its own requirements for elements, although a lot of them are still overlapped. For example, cable and cable carrier, cable fitting, these things are shared in these three later exchanges. Then also each of the exchange has its own requirement for the system. So they're mostly semantic information required by specific semantic information required by each exchange. Okay. So I think we can head to the next session, next part. Yeah.
Thank you, Chi. Yep, we'll pass over to Evandro and Lars for test instructions.
Yes. Hi, everyone. Let me share the screen.
Yep.
I think Ronald, you have to. Yeah, thank you. Okay.
Yeah, we can see your screen, Evandro.
Wonderful. Let me go in presentation mode. Okay.
Yep.
So a quick introduction, Evandro Alfieri, most of you knows me as part of the IFC Rail Technical Service team, or I see some faces I'm happy to see some faces from the IFC Rail Implementers Forum, which I had the pleasure to lead in the last couple of years. It's a great pleasure that you're here because I don't have to go over again these approach that we took in the last 2 years. So you're already familiar with that. But just want to stress the fact that for producing these test instructions, we use very much the same approach. So we use the bottom part of the V model methodology, in which we focused on unit tests, atomic portions that can be easily digested and implemented. Based on these atomic portions, we developed so-called test instruction. You will see in a minute what they are. And these test instructions are not only the guidelines for building the unit tests and undertaking the unit tests if you're a software vendors, but these are also the reference because they contain the validation criteria for whoever later in the process will have to validate and verify the result of a test. Can be a third party, but can be also the very same software vendors doing a self-service job, you know? So the instructions and the validation criteria are contained in the same unique piece of information. So specifically, these test instructions contain the intent. So a brief summary that explains what is the intention of the test, the entities and the concept templates that are covered by that specific test, the preconditions, because some tests might require a precondition to be in place. So specifically, other tests to be done before these very same tests. And then, of course, the validation criteria, meaning all the rules that have to be fulfilled. Of course, many test instructions are also coupled with a specific data set that allows you to build the specific test. The good thing about these test instructions is that they can be chained, so to say, so they can be developed one after the other in these principle of unit testing and then integration testing, but they can also live on a parallel track, so to say. Okay, so they can also be a standalone test. And the good thing of using these modular approach is not only that we can reuse previous tests, but that we can make combinations of test instructions the way we want. Okay, you've heard in the past slides talking about exchanges that we envision that are currently under planning are just collection of test instruction. As you can see here, we can be as flexible as we want, because later, soon enough, we will have a conversation with vendors and probably we have to maybe slightly reshape some exchanges. So taking some test instruction in and out, okay? And this modular approach allows us to play in this way, okay? And also, this modular approach allows, if there are national specificities in the railway project, we have many national specificities, this can be accommodated, taking a test instruction that have been built by our team and using the same methodology and the same framework to extend with other 2 or 3 test instructions that address a specific national requirement so that the software vendor is ready to take on just that portion of tests. Benefit of doing things in this way is that test instruction in this way are modular, can be related or cannot, as you saw, can be expanded for national peculiarities or whatever, can enable in the future self-service test, because again, we use this test-driven development approach. So it's not that you do your development and at the end you test. So the tests are done in a way that you can incorporate these test-driven approach while you develop. So they can be the driver for your implementation. So you can check along the way if you're doing right or not. And most importantly, as you saw, these are tracked on GitHub. So they can be improved. If a couple of vendors go through a test and we find that there is some mistakes or some part that is not clear, we can always fix it and make a new version. About validation criteria, I have to stress this concept. We worked really hard to collect validation criteria in one unique place, in one we call a master document. Okay, it's a document containing all the validation criteria from which all the test instruction can cherry picking and select the validation criteria that applies to this and that case. Okay, so again, this modularity in modularity approach. So these are collected in the master document, which is the figure on the right. I'm going to show you the link in a minute. And these are generic, so they're built in a kind of a template way. So every author of test instruction can cherry pick and extend if needed. Okay, they are technology independent. So these validation criteria are captured in a technology independent way. So regardless, NVIDIA XML, IDS, Python, whatever implementation you might have, we try to capture them as better as possible with plain language, so that can further along in the process, we can choose the best technology that is fit for purpose. Okay, and good to know that these validation criteria leverage on the concept of concept templates. So sorry for the repetition, but these validation criteria builds on top of the concept templates that you find in the IFC specification, often very much often extending those templates, providing a more specific semantic, so-called usages, or even further constraints, you name it. At this point, I'd like to stop talking about the theory and go a little bit more into the practice. And I want to show you a couple of test instructions. I'm going to show you one, and I think Lars is going to show a couple of test instructions. Just for the context, you will see that in the GitHub repository that I will be browsing, you will have test instructions, the yellow boxes, captured under the exchanges that Chi and the others presented. So E1, E2, that corresponds to track, alignment, whatsoever. And inside each of these exchanges, you have a folder with a test ID, in this case, AL22. And inside each folder, you have a README file, which is the test instruction itself. So this README file, this markdown file, you can consider it the test instruction, because this is also the piece of document that you might read, and occasionally it will point to some files in the dataset folder. So this dataset folder is just a container for files that are referenced by the main test instruction document. That said, I hope the overview is clear. I have to stop sharing and jump to, this is one example of the test instruction. As you can see here, I'm in the, let me go a couple of steps back. So you go from general to particular. Okay, so here we're in the repository. You see all the exchanges that we've discussed with their code and their names for better readability. And then inside of each of these exchange, I take the track one. Okay, you have all these subfolders, which are the test instructions. Okay. And here from this README document of the exchange E2A, you have a pretty clear overview of what I was telling about. Okay, so this table capturing the test instructions and the dependency is basically telling you what these image is probably depicting in a clearer way. So Each of these blocks is a test instruction. Okay, you can recognize them by the code. Okay, some of them are related, so-called preconditions test. Okay, so you see, for example, that you have to do the project setup right to do then the global positioning. When you're good with that, you can, for example, make the alignment 22, which is about 2 alignments without count. Okay, on top of that, you can add count if you want and extend the test. So in this way, you can gradually build your complexity, or if you choose, you can only pick 1 or 2 of these, or as you see here, some level crossing tests or some tests for advanced sweep of geometry, which are so-called standalone. Okay, so here you have the overview of the entire exchange, but let me show you an example of one test. In this case, it's an alignment test. I just wanted to give you an overview of the structure of the test instruction. So you see here that all test instructions file have the same setup. They have a kind of header telling you the title, the code, the author, the data owner. Then you have a summary that is telling you which is the intent of the test. In this case, the test is addressing the export. So it's again good to know it's an export test, not for import, and is requiring IFC entities for exchange of railway alignment information without count. Okay. Then there is an overview. In this case, the subject is alignment. So in this case, it's telling you that we have 2 alignments, as you can see from this small picture. We have a couple of alignments. These are the horizontal segments in place, the vertical segments. As you can see, there is no count in this specific test, and no IFC reference file in this case. Then you have another section called itemized routes, which is a articulated name to say scope of entities and scope of templates. Okay, these are the entities that are used by the test, and these are the concept templates, the IFC templates. Okay, section 4 of the documentation that are used by these tests. Then you have a model dataset section. Summarizing what you will find in the dataset subfolder. So a couple of CSV files in this case containing the alignment segments information and the SVG figure that I just showed you before, this one. Okay. Then you have the test case imports, again, another articulated name to say preconditions test. Okay. You have to do project setup, you have to do global positioning before doing these alignment 22 tests. Expected results is a fixed section, so to say, because it's telling you all the test instruction will find the same thing. Okay, the expected results for the certification of capabilities is always, in this case, for an export test, 1 IFC files containing the information as request and named after these convention. Okay, nothing very particular. Most importantly, at the end, you have the validation criteria, which is the collection of criteria of rules that you have to fulfill. We've divided them on topics, so you will find some generic rules, some railway alignment specific rules, some spatial decomposition rules, spatial containment, depending on the complexity and the scope of the test. But just let me give you an idea of how these rules works. Every rule has an ID, okay, to be always referenced, and these IDs harmonize in the validation criteria master document. So we made sure that this is consistent. Some rules are in the form of direct values. Let me take one. For example, this alignment 1, number of alignments containing file 2. Okay, this is a direct value that each author of a test instruction should copy and fill in according to the data set and to the test instruction. Some other rules points to other tables. Let's take the example of these generic rule number 1. Okay, all requested entities and attributes exist in file. There is no fixed value. The value is as per entities table, which is the guide that you see here. Okay, so in this entity table, you will find all the elements that you need to have in the test with the attributes that are of interest of this test. So in this case, you will have a couple of alignments elements, okay, with name, object type, predefined type. And with these values, these are the expected values. Same for horizontal, vertical, okay, you will have a couple of them. IFC site, named in this way, IFC railway, named in this way, and so on and so forth. You got the concept. So this is to say, some rules have a direct value, some rules points to other tables. Let me just give you another example. Alignment layout structure is verified. So per se is not really explicit as a rule, but because this is a more complex rule, and you have to see the steps of this rule, which are here, okay? Each IFC alignment must nest exactly one IFC alignment horizontal, or each IFC alignment horizontal must be nested only by one IFC alignment. So here you have all the steps that all together allows you to fulfill this rule. I don't want to go into all the complexity of these. I just want to maybe point out the validation criteria master document to just show you what I was mentioning before. In this document, we have all the tables template that we used before. So in the test instructions, so the entity table template, the alignment table template, groups, spatial decomposition. I mean, every capabilities, almost every capability has its own table. And then we have the validation criteria, which again have been divided given the capabilities. So general, project setup, alignment, alignment import, super elevation. I mean, all those capabilities. With that said, I think I took too much, so I would like to hand over to Lars to give you another impression of these, how this test instruction works.
Okay, thank you, Evandro. Yeah, my name is Lars Wikstrom. I've been working mostly with the IFC Road project and also in IFC Rail technical services. And yeah, as Evandro said, I will just show you some more examples of these test instructions that we have been working with. So in this case, I'm actually starting with the alignment reference super elevation exchange, which is sort of divided into two parts. One is the infrastructure alignment curves, and as you see here, we have actually 6 of those cases. And I should also mention that I've not been working with these alone. I've had great help of Juha Liukas and Hyvärinen from Finland, and also Karin Andersson helped me with particular cases. So one issue that we had, and that also Chi mentioned, was that, I mean, we have all these different kinds of transition curves, for example. So what we have done here is that we have specified maybe first an alignment layout with no geometry at all, just the layout with the semantic definitions. And you see here what kind of elements we use. So we have 2 of those cases where we have either circular arcs or parabolic arcs in the vertical alignment. We have one case with a simple polyline representation. And then we have cases where we have actually the same alignment layouts, but we instead also add geometries in the shape of composite curves and gradient curves. And then we also have 2 separate cases then for super elevation with one case and super elevation plus width in another case. So you recognize the structure that Evandro showed you. So we have a test instruction with the README and the summary intent. And in the same fashion as Evandro showed you, we have listed the entities in the test case and also the concept templates. And we have the table with the input data that can be used for, or that should be used for this test instruction. And in this case, we have actually no imports. All the necessary information is actually contained in this test instruction. We have the expected results, same as Evandro showed, and then we have the validation criteria. And in this case, it's a lot of copying then. Since these rules are sort of generic, it's a matter of picking the rules necessary for this particular case. So we have the generic validation criteria. We have criteria for the alignment with steps, again, as you saw for this alignment 0. Should be 1 alignment in this file. We have spatial decomposition. Quite simple in this case. We have just project and site. And actually, you saw in Evandro's case, he actually had the tables with the entities and all the information in the same file. I have actually, well, see how we do. We have this dataset folder with a separate README file. So I've actually collected everything about the dataset in there. So if we, for example, look at product geometric representation, which we have in this case, we can click this link and we end up in the description of the geometric representation for the alignment and the horizontal and the vertical. So then if we go back again, I have also some information then which is necessary here, since we don't import any other test instructions. We have actually also described the parameters needed for project setup and also for project global positioning. And you are, of course, expected then to use the correct templates for that. And if we then go down to the dataset folder, you have here CSV files for the alignment parameters. You have a land XML file, and currently there is also actually an example IFC file here. But anyway, the dataset is described, what it should contain, and then you have sort of all the different tables here, like the entities table with the attributes that you need to set, only name here, and we have the alignment segment parameters for the horizontal alignment, the vertical alignment, and then you have the description on spatial decomposition, spatial containment, geometric representation, and placement. So this is one case, and I should maybe also show you then we have this super elevation exchange. And in this case, we have 2 test instructions for this, one with only super elevation and one with super elevation plus widths. And if we take a look at the super elevation one, it sort of, again, has the same structure. It has its ID. And again, it has its entities and concept templates. And the same kind of validation criteria again, with some additions compared to the previous case I showed you. And also in this case, we actually linked this case with the one I just showed you. So it actually uses the exact alignment from the test instruction I showed you before. So this one actually just adds the things needed for super elevation and widths. And if we go into the dataset folder here, you have again the datasets needed, and you have also an illustration of the case that we are testing. And some more than information in the different tables. So you have the annotations for super elevation added with their names, the definition of the content of the property sets needed, in this case then P set super elevation, with, let me see if I can scroll here, with the values you need to set also. And then we have again spatial containment. In this case, we have product relative positioning, so all the super elevation annotations are expected to reference the alignment as a positioning element. We have the product placement with the linear placements of the super elevation events, and then this illustration of what we are trying to test. So those are actually the two examples that I plan to show you. So over to whoever it was.
Thank you, Lars. I think we're going to Matthias next.
Yeah, it's me. So thank you, Lars. So we have seen a lot of content that is needed to set up the software certification. My name is Matthias Weise. I am a member of the software certification team. I have been involved in software certification since IFC 2x3. I went through the changes also with software certification for IFC 4, which you see here on the slide. I would like to briefly go through the software certification as it is available right now, and where to find the information that we have seen in the previous slides from the other authors. So therefore, just to give you an overview, so everybody who is not familiar with the software certification, I do not want to talk about the reason why we need software certification. I want to show you a little bit how it is defined in the BCert platform, which is used to support the software certification. So you see here a screenshot which shows you, for instance, that there is a set of different software vendors being certified. We see the schema. So in our case here, IFC 4, of course, this will then be, of course, updated to IFC 4.3. We also see the model view definition that is being certified. So here, in that case, against the reference view, which is also the basis for the alignment-based reference view. And we also see the exchanges. So in that case, it is architectural, structural, MEP. What we see here. And this is the basic setup. So each software vendor can decide. So what is the exchange he wants to certify in the software certification process. You also see the type. So you see export, you see import, you also see both. And this is also then reported on the websites from buildingSMART. So who has passed which exchange, which more or less defines which storylines or use cases are supported. So next slide, please. So here you see already some trial setup for importing release candidate 3 from IFC 4.3. So this is basically the schema definition. So next slide, please. So it's just going through. I give you some impressions here. So Ronald, if you can go to the next slide, please. So here we more or less in a slightly different screenshot or way that we have seen also in the GitHub repository. You see a list of test cases. So on the left, you see, for instance, test cases for a beam. There are two types for the architectural exchange, for the structural exchange. So they are based on a similar setup, but are asking different properties, different IFC features that are being certified for the exchange. So this is basically the list. So a similar setup, of course, would then be necessary for the alignment-based reference view, having also the set of exchanges that we have seen in the slide from Sergej, Chi, and in the previous slides. So next one, please. Here, again, you see also similar things that was shown already by Evandro and Lars. So here are the concept templates. So we have seen that also in the scope definition from Sergej, for instance. So each test case is then split up into functionalities, and each of these functionalities is being tested in the software certification process. So we have for this test case, beam, and that case, we have a set of instances where we ask for specific values, and each let's say functionality for a specific instance is being tested and also documented in this platform. So next slide, please. So the way how we do the check, so we actually, so first of all, this was also a lesson learned from IFC 2x3. With the new IFC 4 certification, we try to automate as much as possible, so to reduce the effort and also the delays, because we wanted to reduce the amount of manual checking. So therefore, we are still two parts. So the first one, the automatic checking part, and the second one, the manual check. And we want to start as a software certification team doing also the manual checks mainly. We want to start when everything from an automatic check passes. So this is also something where software vendors can upload an IFC file, can do the automatic checking, get a feedback, an error report, can fix that. And if everything passes, so then we can start the manual check that normally takes more time and is also, I mean, what is at the end time consuming and also costs money. So next slide, please. So here I want to show you what is being checked, also in particular in the automatic check. Of course, we have as a basis for the software certification, we have a check against the whole IFC specification. So using the express schema definition from IFC 4. So this is an automatic process. So where are, of course, all the entities, the attributes with the data types, we have cardinalities, constraints in terms of their rules. So this should apply to an IFC file that should pass the software certification. Then we also check, of course, the step physical file if the encoding is correct. So certification is, at least at the moment, based on the IFC files. Of course, there's also IFC XML, but this is not yet really tested in the software certification. The next step, we have also heard about the subset express schema from Sergej. We have heard about MVD XML, so which is the basis to encode the MVD. So this is another check that is done. So there are additional agreements encoded in MVD XML, for instance. We also have the subset express schema. So where some entities are not supported, some attributes, references are not supported. So this is being checked here. And then we have, so this is the next main step to set up the software certification. We have a test case specific checking rules. So we have seen the test instructions asking for a particular instance with particular values. And this will be encoded also in MVD XML to check that, I don't know, the beam CR1, for instance, has a specific property or is part of a special spatial structure, etc. And then last but not least, we have additional quality checks, something that can, for instance, not be encoded in MVD XML. There are, for instance, agreements about proper file header, where we find, for instance, the information. So what is the model view definition? What is the exchange? We also have additional rules for checking the geometry. So tools have been developed also in the deployment project, checking, for instance, that the business definitions apply to the geometry that is maybe part of an IFC file. This requires additional tools that are encoded in some programming language, but should also be used in the software certification. So next slide, maybe you can skip then, you can directly go to some sort of next steps or summary. We have seen, I mean, we are more or less in the end phase, but of course we need, in order to do this automatic checking, we need the MVD encoded as MVD XML. So here we also have a newer version from MVD XML. So in IFC 4, we are still using 1.1, whereas 1.2 with some improvements also for model checking. We need this subset express schema, which is automatically generated. We have seen the IFC doc tool from Sergej, which can do that. Then this is the major work that has to be done based on the test instructions. We have to encode the test cases into a test case specific MVD XML files. So they are also then available for download. So all software vendors can also check the encoded rules if they want to do it. But of course, they can also upload an IFC file, use the service, and get a result. And then, as mentioned, we also want to take over additional checking tools that have been developed in the previous phase. So next slide, please. So this was more a technical view. Of course, there's also a little bit a management view. So what are the next steps? Of course, we have to do a review. Sergej pointed to the documents to give feedback, to write an issue in the GitHub repository. We also need, of course, the commitment by software vendors to say, I want to be certified against a particular exchange, maybe for also for import or both. So this is something where we need some discussion and to get an overview. And this is also important for further resource planning from the certification team and also to clarify financing of the software certification. So because this is also software vendors has to pay for the software certification to let's say support the effort being done by the software certification. So that was my last slide. So thank you for your attention and would like to hand over to Christophe.
Thank you, Matthias. Christophe,
Yes.
are you able to take us through the ISO process?
I think I am able.
I'm sure you are. Go ahead.
Now, just to say that before to start that I'm very impressed by the presentation coming from the previous speaker about the quality of, in terms of the effort done about to industrialize, in terms of industrialization of the IFC product through the test instruction and so on. It's very close to commissioning process, and I think it has to be said here that it is a really great effort and very, very important for the end user. So I need to go to my presentation. Okay, to the beginning, better. Okay. Okay, my present today is just to introduce, because we are quite completed two aspects of the development of IFC 4.3. First of all, is the skimmer, and secondly, the works in produce here in terms of MVD preparation to certify the content. And we are starting on next week, the 6th of April, the first meeting of the Joint Working Group 12 of DC59 for the approval of the new extension of IFC. So what is important to say regarding the process, what I want to underline. First of all, what it is issued to ISO is the release 4 of IFC 4.3. That is important. Even it is not appears on the documentation, because it was we apply a quality system to show to ISO the first version issued to ISO, but in reality it is a release 4 issued to ISO. It's important to say that. And secondly, what is important to say that is for buildingSMART at the end of the process to produce a production standard. If I say that, is because that means that in the agreement between buildingSMART and ISO, and just to underline that the process is unique for ISO and CEN, is because if it is considered by the standard committee of buildingSMART as a production standard, we are starting right now, sorry, in this process of the IAS meeting. It means that we consider that the documentation issued to ISO is already not only a draft, but a standard, a pass, as a pass documentation, not a draft. So regarding that, what does it mean? That we had during January the new work item ballots. I'm going to come back to the results. The result is positive in any case. And we already starting the discussion on the documentation for approval the 6th of April, in less than 1 week. And the process, which is common to ISO and CEN, because we apply immediately the Vienna agreement, is to go to publish as approved this documentation for the beginning of next year. Okay, so you have not so much time for that, but we are online. The Joint Working Group 12 has to be said that the convener is Thomas Libisch, which is not a surprise. And we introduced the topic on the plenary session of TC59 in November and October, and TC 44.2 in Seine in November 10th of this year. How we proceed? We have two key moments for that. Is a process starting in 15th of February to verify if we can to stop and to fix all of the issue to be on the modification of the schema, in order to have on 22nd of February the assembly with the implementer, the general assembly of implementers, which was introduced. The 6th of March, we send the documentation to ISO based on the all of the issue fixed in GitHub. And we have this meeting 1 month later for the presentation of the documentation. The documentation, what we have to know, I already said that there is ISO 4.3 release 4. All of this element of the documentation are available on the website of the technical website of buildingSMART with this link. And if you want to have the Express schema to be used, you have the address here. So the Express is part of the documentation. I'm going to prepare for the Joint Working Group 12 documentation to explain how that works, in order to help the people in the ISO process to understand the content and to go what it is important and what it is less important. Regarding the process in progress with ISO, we have already first meeting to analyze the result of the ballot. We know that we have 25 yes and 8 abstention coming back for that, and some confusion about is it draft or pass. It's important, and the first meeting was from China representative, France, Germany, Norway, UK, and Australia. If I give this information, is because it's not too late to come back to the national standard organization to have experts involved in the first meeting. I'm not going to repeat that, but what we have to know that there is still some expert to be committed for that, and some country are saying that their abstention, the 8 here, is due to the fact that they are not expert enough involved on that to provide any view about approval or not approval of that. And what is also important to note, I'm going to re-summarize that here, that we know already that for the attendee of the meeting of next week, Australia, Austria, China, Finland, France, and Germany have already committed their expert. Some countries are still willing for that, Portugal, Swiss, Turkey. Some countries are in progress for the commissioning, Canada, Denmark, Netherlands. Sweden is already done. I received the name this week. And we have no feedback for the country like that: Belgium, Italy, Japan, Korea, Norway. It's surprising, Norway. Russia, we can understand why. Singapore, Slovenia, Spain. Slovenia, I say that to Sergej, if you can help us for that, would be great. And I'm going to ask also to Vaiko, Spain, UK, and US. But in any case, all of these countries have approved that. Just to summarize what I said today, that it's not a new schema, it's an extension. So the target is not to rediscuss the content of IFC 4, it's really to discuss about the extension and the new domain involved in that, with new entities and the evolution of existing OTT with some extension of that. Something to be noted that the delivery of that is also linked with a new utilization, a new usage of BSDD. And it's important to know that, because that means that in the discussion of the MVD, we are discussing about the schema as it is. But if you have a look about the huge works done about defining properties and semantics on a large aspect of any domains of infra, the impact of ISO is much more than only the schema, but is going deeper in terms of defining much more than the geometry. It's not only on geometry; it's also the capacity to take into account really the element of performance of the building of the works, and it's really in line with the perspective of the digital twin and the perspective of the management of the climate, the new circular economy. It was mentioned here that the extension of the MVD for alignment base, and just a comment about the discussion on the chat, that alignment-based reference is not going to solve everything. Any aspect of any domain of IC 4.3 is really to concentrate of the aspect of what it is. The main extension of IFC4 is regarding the question of alignment and geospatial referencing, and it's really something to be very. So I appreciate very much what you've done here, because to arrive with ISO to explaining that we have already the commissioning of that and some experimentation and implementation with software vendors about that is something helping very much to proceed as fast as possible to the approval of ISO. We have the extension, the new version of buildingSMART mentioned by Matthias, and what it has to be said that this documentation, including the extension, the latest version provided by Rail, about what is the content and the schema covered by IFC. It's important to say that we are going to provide that also to ISO in order to have something to explain in more technical. But when I say technical in this aspect, it's more related to the domain expertise of the impact of IFC. That is the architecture of the documentation we can find here on this link. And just to conclude, the agenda of next week will be focused on two aspects. Do we need or not a ballot for defining the process draft of pass? What it has to be said that normally but it was I think it will be not a problem. The idea is really to come back to the protocol between ISO and buildingSMART. buildingSMART are the copyright of IFC, and the protocol say that if buildingSMART is able to submit a product standard, we can go directly to the pass. Well, in any case, if we so that means it's really a fast track procedure. But in any case, if we don't want to make a political issue regarding that, if a ballot it is needed to move to pass, we are going to proceed for that, and it does not make any effect about the second aspect of the agenda, is how to work on the documentation, and we are going to proceed in this way. First of all, to concentrate about and to make selection about the comment in two parts: editorial and technical. Editorial means that we are that means is a modification of human readable aspect of the documentation with better explanation or something like that, with no impact on the schema. So we are going to be very open on that, very flexible, and to have a committee. We are going to create a committee in buildingSMART in order to analyze the comments and so on, and to be very open for any modification if it's really helpful for the understanding of the schema and how to apply that, maybe on an element of the concept template or something like that, which are important for the software vendors, but also for the end user to understand how to implement in the project the schema. Technical, it means what is the comments which with some impact on the schema. We will be flexible too, but in other way. it's more complicated. But in any case, what we are going to say that we want to have an approval of the scheme as it is today. If there is no, if it appears that there is no major issue about that, and with what we are already implemented in the implementer form, prove that we can move in this direction. But in any case, we can accept any comment of technical if we are able to embed that in the release arriving next year or a little bit later with IFC bridge, because we are continuing to extend the skimmer with IFC tunnel. Sorry, I wanted to say IFC tunnel and geotechnical. And we know that in any case, we'll be very open to accept that, but manage in the releases arriving for IFC tunnel, which will be also a major extension of the skimmer. Thank you. I hope I was in time. And thank you for your attention.
Thank you, Christophe. Yes, that was perfect timing. It's locally in the UK, it's 2:30. In Central Europe, it's 3:30. It's various different times all around the world for the people who've joined us today. But we're exactly on time. So let's just deal with one or two of the comments and questions that have come in through the chat whilst the excellent presentation that we've just heard has been provided to us. I see Sergej has answered and provided many links to where different documentation is available through GitHub or indeed other online resources. So thank you for that, Sergej. Probably start with a question that came in for yourself, Christophe, as you were presenting the ISO process. Winfried Stix, hi Winfried, was asking when you were showing the countries that are reviewing IFC 4.3 as part of the ISO process, is there a list of names of people in those countries? Yes. Who are the ISO reps? Okay.
Yes. And I have the list, but I think it's complicated because it's a private documentation from ISO, so I'm not sure that I have the right to publish that.
Yeah, fair enough. Well, maybe if you check for us.
Yeah, yes, but when I am sure that there is nobody coming from Austria, Winfried. So if you can do something for that, could be great. Okay. We know also that we are looking for. I already communicate to Switzerland that there are people are missing, and it's really a pity because SBB was very much involved in that. So it's really a pity to not have that. So I've already I also communicated to Xenia and to Evandro about how to proceed to have some people involved in that. Again, it would be a pity to have anybody from Italy on that.
That's great. Thank you, Christophe. Perhaps you could have a private conversation with Winfried about Austria as well. Lovely, thank you. Sergej, is there anything that you wanted to add to the various comments in the chat and questions in the chat that you've already answered?
Not really. I think Christophe summarized it perfectly, expecting that the alignment-based reference view is suddenly going to resolve everything. We shouldn't do that. We should be realistic and just take it for what it is, and that's of course the base for exchanges and infrastructure, and everything based on that is of course a bit of additional work to do.
Yeah, indeed. I mean, there's always, as you say, the work that's been done to date is fantastic, but there is always more development to do. Is there anything you wanted to add or say? I saw you had an exchange with Ron Broikula. Thank you, Ron, for your comments and questions on how the MVDs will be used by software vendors and how the different implementations will work in different countries, I think, essentially. Is there anything that you wanted to just say to the audience about that exchange?
You mean me?
Yep, Sergej. Yeah, did you were talking to Ron in the chat, I think, weren't you? Yes. About how different MVDs that have been developed will be supported by the software vendors, and how differences in approach in different countries will work essentially.
So what we have to keep in mind there is that, of course, the base MVD, what we see in alignment-based reference view is the MVD that's supposed to give us an idea of the capabilities of software. It's not there to facilitate individual exchanges on local level or even going as far as project level. Stakeholders will always have their own requirements of how to structure data. And IFC with alignment-based reference view is there to provide the framework for it. It's not there to structure data for anyone. And of course, there are various systems in play here where we have different databases structured differently. And of course, if we want to use IFC to feed that, and we have to keep in mind that IFC is basically an exchange format. It's not an archiving format or something like that.
Yep.
If we want to facilitate these exchanges and these handovers, then data has to be possible to structure in various ways. And we also have to keep in mind always that we are modeling the built world with something like 2,000 properties and 1,000 entities. It might seem a lot, but we are modeling the entire built world, so there has to be some generic approaches to modeling data, because you can't cover everything, obviously.
Yep, that's very true. Thank you for that. Looking down the other comments and that are in the chat, I think we've handled them through the presentation, or indeed in the comments that panelists have added into the chat. People are asking how or whether they can have access to the slides that have been presented today. Yes, the slides. This session's been recorded and it'll be made available through the BSI website in the next few days, so that people can replay it and come and access any part of it that they wish to see again. We will also gather up the slides that various people have presented and make those available. And as I said at the beginning of the session, any expert panel members who wish to provide comments on the documentation or on what they've seen and heard today in the presentation can do so. There are some links at the beginning of today's chat, at the beginning of today's presentation, which give you access to a comments log. But again, we'll also make that available when we provide buildingSMART provides a package of the slides, the various links of the data, and the comments log for expert panel members to provide comments. So all that remains is for me to thank all of our presenters today. As I said, it was an excellent presentation, and it was very well structured in terms of the order and the different topics that were covered, very comprehensive. Thank you to the Rail project, thank you to the Infrastructure Extensions Deployment project. And I'd like to say that at the peak, we had well over 100 people with us. So thank you to everyone who has attended today.
No, one remark, we have a new expert involved in the project here with Stefan.
Yeah, hello Stefan, welcome to the project.
Yeah.
That's great. All right, thanks very much guys. See you again soon.
Bye-bye.
Cheers.
Thank you all. Thank you.
Thank you.
Thank you all.
Bye-bye.
Thank you, bye-bye.